When we look at the night sky, every star looks like a tiny point of light. We call it a point source. Basically, the stars are so far away that they may take up only a single pixel on a detector. And that makes it hard to determine how far these things are. Is a really bright star a close star that's really small? Or is it a really, really distant star that's just enormous? Astronomers can figure this out using parallax. It's one of the most powerful tools in astronomy, and you're seeing it in this animation. Remember that the Earth is orbiting around the sun. And if you imagine speeding up that process and taking an image every month as the Earth orbits around the sun, what you would realize is that there were certain stars that appeared to be moving faster, moving more than other stars in the background. In reality, this effect is tiny, like fractions of a degree. It's greatly exaggerated here in this animation so that you can see what's happening. You also notice you can see Orion's belt here. The Orion constellation is right here. It's pretty cool. Using parallax like this was the first way astronomers were able to pin down stars' exact distances from our solar system. You experience this every day. When you're in a car driving, it seems like the trees are whipping past you really fast, and the objects that are farther off in the distance appear to be moving slower. This is just parallax. That's all it is. Measuring parallax, missions like Gaia has been able to give us a realistic 3D map of the stars in the Milky Way. Gaia is also able to measure small sideways shifts called proper motion and motion to and away from us called radial velocity by looking at these stellar spectra and accurately map not only where the stars are, but what direction they're moving in. It's very cool. It's all physics. And as an exoplanet researcher, I'm going to go ahead and remind you that most of these stars likely have planets that we will simply just never be able to detect.